In this video, I want to talk about when are two graphs the same. And you'll notice that this is exactly the same graph definition for the graph that I drew in example 0.1. So now let's imagine two different people, person one and person two, interacting with this definition of this graph G. Person one might, let's say person one draws the graph over here and person two draws the graph over here. Now person one might draw the graph in exactly the same way that I drew it. They might say, okay, V1, V2, V3, V4, let's see, there's an edge from V1 to V2, an edge from V2 to V3, an edge from V3 to V1 because, right, V1 to V1, V3 is the same as V3, V1, so we have that, we have that. Now person two might come along and say, okay, well, let's see, my vertices, let's draw those. You got V1, you got V2, you got V3, you got V4. All right, and there's an edge from V1 to V2, from V2 to V3, from V1 to V3, and from V3 to V4. And these should be the same, right? Because they have the same definition. And in fact, they are. In graph theory, we consider these two graphs to be the same graph. All right, because in graph theory, or graph theory itself is the geometry of position. All that matters is the positional relationships. And what I mean by that is looking at V2 here, right? V2, there is an edge from V1 to V2 that touches V2, and there's an edge from V2 to V3 that touches V2, right? And those same edges, those same relationships are preserved for this vertex, V2, right? There's an edge from V1 to V2 and an edge from V2 to V3. There's an edge here from V2 to V3. There's an edge here from V2 to V3. There's an edge here from V1 to V2, here from V1 to V2, and here from V1 to V2. Let's see, looking at V3 here, right? V3 has three edges touching it. It has an edge from V1, an edge from V2, and an edge from V3. And look, or from V4, sorry, there's an edge from V4. And look here, right? There's an edge from V1, from V2, and V4. Right, so these two graphs hold exactly the same relationships between edges and vertices, and so they are in fact the same graph. So how to tell? Well, there's an exact way to tell, and that's defined in section 13.2, and we would say that these two graphs are isomorphic. But we're not going to be too formal here. The way to see if two smaller graphs, and smaller I mean there's a small amount of vertices, is to think to yourself, okay, so the way I see this is I think, okay, I look at this graph here and I say to myself, could I pick this up off the page and through stretching or shrinking the lengths of the edges and moving the positions of the dots, create this graph and set it down on top of it. All right, now see, let's see here. Now, how could I do that? Well, let's see. Let's take V3. Let's take V3 and move him over a little bit. And take V1 and move him down a little bit. Okay, let's do that first. All right, so if I moved V1 down a little bit and V3 over a little bit, then I would have this, right? Let's see. If you think of this edge in blue here, that would become that edge there, right? If you think of this edge in red here, that would be that edge there. This one as green, that would be that edge there. And this same edge right here is exactly that same edge right there. Now to make that into the other one, I've got to move, to make this look like the other graph, I've got to move this guy over here. And that's certainly fine. I can do that. I can do that with graph theory, the geometry of position. That's okay. And so these are, in fact, the same graph. So think about how could you possibly take this graph over here, this graph right here, think about picking him up off the page, visualize this in your mind, moving V1 down a little bit, moving V3 over a little bit, and then moving V4 around to this other side, and you can see that we can take one graph and turn it into the other. And so if you can do that, then the two graphs are the same.